Fire residue is not only a matter of soiling and odor. Depending on what has burned, it may carry a range of chemical contaminants of genuine toxicological importance. Recognizing which of these may be present and understanding why is essential in protecting occupants and restoration workers, and to deciding how the residue must be handled and disposed of. The most consistently important group is the polyaromatic hydrocarbons, or PAHs. PAHs are formed during incomplete combustion of organic materials and are almost always associated with soot. Several of them, of which the benzo pyrene is the most widely cited, are recognized as carcinogenic. Because PAHs absorb onto the surfaces of fine soot particles, they are carried wherever the soot travels, and they may therefore be present on surfaces that show very or little visible staining. This is one of the reasons the extent of a PAH concerns cannot be judged by eye. The second important group is the dioxins and furans, or more precisely the polychlorinated dibenzodioxins and dibenzofurans. These are formed when materials contaminated chlorine are burned, most notably the polyvinyl chloride, or PVC, which is widespread in modern buildings in the form of pipework, cable insulation, floor covering and window frames. Dioxins and furans are persistent and toxic even at very low levels, and their potential presence is one of the main reasons that fires involving significant quantities of PVC warrant a particular case. Polychlorinated biphenyls, or PCBs, represent a related concern. Although the manufacture has long been prohibited, PVC remain present in some older electrical equipment, transformers and capacitors, and in certain historic materials. Where such equipment is involved in a fire, PCBs, together with the dioxin and furans that can form from them under heat, may occur in the residue. The age and history of the building is therefore relevant to what maybe need to be considered. Fire residue may also contain heavy metals. The combustion of electronic equipment, batteries, wiring, pigments, and treated materials can release metals such as lead, cadmium, arsenic into the soot and the ash. Unlike organic compounds, metals do not degrade over time. They persist in the residue and must be removed physically rather than allowed to break down. Their presence can also complicate the classification and disposal of the waste in the remediation generates. A defining feature of all of these contaminants is that their presence and their relative importance depends on what has actually burned. A fire, for example, in a timber store, a domestic kitchen, or an electric substation or a warehouse of plastics will each produce a residue with very different chemical profiles. There is no single contaminants that characterize every fire, and there is no benefit and considerable cost in testing indiscriminately for all of them. This is precisely why chemical assessment is targeted rather than comprehensive. The relevant analytes, whether it is the PAHs, dioxins and furans, PCBs or specific metals, are selected on the basis of the material known to have been involved, the circumstances of the fire, and the clearly defined objective established through discussion with a competent professional. Testing is directed only at the substances that could realistically be present and that would actually influence a decision about protection, cleaning or clearance. It should be emphasized that the possibility of those contaminants is not a cause for alarm, but for competent, proportionate assessment. Their concentration vary enormously from one incident to another, and the appropriate control measures, protective equipment and cleaning methods all follow from a measured evaluation of what is genuinely present. In occupational terms, the handling of substances hazardous to health is in any case governed by the control of substances hazardous to health regulations, which require exposure to be assessed and adequately controlled. So, in summary of all of this, the toxic potential of fire residue derives principally from PAHs, dioxins and furans, in rare cases from PVC and heavy metals. In combination, that depends on the fuel involved. Identifying which of them are plausibly present and then testing for those selectively is what allows the hazard to be properly understood and managed, without unnecessary cost, delay, or alarm.